So we've talked a lot about the image-to-image architectures and how they train. But I want to take a step back and talk about why CycleGANs work in the first place. How is it possible to learn a mapping between a set of images X and another set Y, so that you can translate from one domain to another? We are operating on the assumption that the style and content of an image can be separated. And this is exactly what the convolutional layers in our generators are learning to do. So the encoder half of a generator is a convolutional neural network whose job is to extract features from an image that distill information about the content of that image and discard any extraneous information. That is, as we go deeper into the layers of this encoder, the input image is transformed into feature maps that increasingly care about the content of the image, rather than the detail about the texture and color of pixels, which is something close to style. And the generators have to learn to preserve the content of an image, so that they can take in an image X and produce a differently styled image, and then take a style image and produce a good reconstruction version of X. In fact, the cycle consistency loss that tracks on how the generators map an image from X to Y and back again is what ends up preserving the content of an image. The adversarial loss from the discriminators in the CycleGAN are responsible for training a network to produce images in a realistic X or Y style. So a complete CycleGAN is trained to separate the content style of a set of input images. For any new image it sees, it will be able to keep the content of the image and transfer the style of a whole collection X or Y to it. This separation of style and content makes CycleGAN useful for a number of applications. Collection style transfer, as you have seen, where we want to transform any input image in the general style of an artist. You can use it to do some interesting photo transformations, like altering images so that they look like they are taken during summer or during winter, or changing images of apples into oranges, or dogs into cats, and vice versa. It has been used to try to transform one person's face into another. In addition to photo transformation and enhancement, CycleGAN has been used to effectively adapt a semantic segmentation model across domains, such as from GTA 5 to German Street View and transformations from Google Maps to satellite images. CycleGAN not only works on images, but also on other data, like motion or auditory data, such as speech recordings. Imagine that you want to transform my voice into your voice. You could do so with the modified CycleGAN. The applications of such a model are very far-reaching.